Composition of functions is a concept that's often confused with multiplying two functions. In this particular case, we have a function f of x equals 3x minus 2, and g of x equals negative 2x squared minus 5x. The way we would write a composition of functions is f of x, and then this sort of open dot, and then g of x. Now, if we were looking at a multiplication problem, which you will see on the test along with composition of functions, we would have a filled in dot. The difference is subtle, but I just wanted to make sure that you were aware of it. Right now we're going to talk about composition of functions, not multiplying two functions. With composition of functions, the thing that we're trying to accomplish is we're trying to put one function inside of the other. So in this particular case, I'm going to go ahead and I'm going to write it out so it's a little more obvious. Another way to write this guy, and this is important, is that we write it like this. So if I have a composition of functions where it's f of x and then the composition of g of x, another way to write it is f of g of x. And it's probably worthwhile for you to write down how to say it and for you to practice saying it. What we're looking at here is f of g of x. That's what this guy is. In the past, we said f of x, and we said that meant y. In this case, it's f of g of x. G of x is a y, and f of g of x is another sort of a y. And we'll talk about that more in a bit. Now, since we're saying that we're going to put g of x into f of x, what we're going to do is we're going to replace the x in f of x like such. We're going to just put parentheses instead of x minus 2. Now, this is something that you should have been doing all along. Whenever you wanted to put some value of x into a function, normally you should have written x as a set of parentheses, and then 3 times that set of parentheses minus 2 gets you your y value. So this isn't all that different. The only difference is now we're going to squeeze into these parentheses g of x, because that's what it says right here. So this guy right here, we're going to squeeze into here. And I'm going to go ahead and write it. It's negative 2x squared minus 5x. And it'll be 3 times all of that minus 2. That's f of g of x. Now I'm going to go ahead and write it all out. So in this problem, we'll distribute the 3. And that'll give us 3 times negative 2 is negative 6x squared, and then 3 times negative 5 is negative 15x, and then finally minus 2. Now, I can see how a student, when they first run into this, could think to themselves that I'm just multiplying these two functions together, because it almost looks like it. I mean, I'm multiplying the 3 times the other function, but I'm not really. What I'm doing is I'm putting this guy inside of the x of this guy. And in a minute I'll show you why it works out that way. But in the end, this is our end result that we're looking for. F of g of x is negative 6x squared minus 15x minus 2. So we kind of accomplished our goal. We were able to do this thing. That's what we wanted. And if I want, in the end, I'll wrap it up by rewriting all that. So voila, here is our answer. Now you'll notice that in the end I rewrite the composition part so that it's clear what's going on. And you'll notice that I wrote it in a slightly different way. These two statements are equivalent. If I write something like this, that has the same meaning as f of x composition g of x. We can write f composition g of x, and that's fine. Anyways, this is the final answer for f of g of x for these two functions. So let's take a look and see, why does composition of functions work this way?